This is CPT. As we discussed actually already, we are discussing penetration tests. Within the penetration tests, we have discussed SPT. This time we are discussing CPT, cone penetration test. Actually, when it comes to cone penetration test, it is done in two ways. Let me write now. There are two ways. One is static cone penetration test. Second one is dynamic cone penetration test. Static and dynamic. We can conduct this test in two ways, either by applying static energy or by applying dynamic energy. This is what we have discussed in the case of SPT, standard penetration test. To be frank, we have applied dynamic energy in order to penetrate the split pool sampler into the ground. In order to penetrate the split pool sampler into the ground soil. Okay. Now in this class, we are going to discuss CPT. This CPT can be performed in two ways. One is in statically. That means we are trying to push. We use actually cone, where we are using a cone. Cone, we are trying to penetrate the soil through cone. But whereas in the split pool sampler, we used a sampling tube, that is split. Whereas in SPT, we used a split pool sampler. Here we are trying to penetrate cone. Let me tell you about this cone. This is the shape of the cone. This is the shape of the cone. This apex angle is 60 degrees. Apex angle is 60 degrees. And let me tell you, the diameter of the cone is 35.7 mm. 35.7 mm. You can, if you are not ready to remember this figure, you can remember 36 mm. Okay. So please keep these points in your mind. We are trying to penetrate cone into the soil. This is the cone. The apex angle is 60 degrees. And the diameter, this is a symbol of diameter, is 35.7 mm. And the end area, if somebody is trying to measure the area, end area is 10 centimeter per 10 centimeter square. 10 centimeter square. So now actually this SCPT, static cone penetration test, is also called Dutch cone test. Dutch cone test. Dutch cone test. It is also called, another name is also there, which is very popular for this cone penetration test, that is Dutch cone test. Actually, as I mentioned, in Dutch cone test, we used to use a Dutch cone which has an apex angle of 60 degrees and overall diameter 35.7, which in turn gives an end area of 10 centimeter square. 10 centimeter square. Now what I am doing now, see now, so we used to have a drilling rod. This is the drilling rod. Drilling rod. The end of the drilling rod is attached with cone. The end of the drilling rod attached with cone. So here you see this drilling rod, the end of the drilling rod. In earlier case, we attached with split pool sampler. In earlier case means in case of standard penetration test. Now we are discussing about cone penetration test. The name itself is saying we are going to attach cone at the end of the drilling rod. Now what we are doing, please write. Let me write it. For obtaining cone resistance. Somebody can ask me, what is cone resistance? See, when we are penetrating cone into the ground, see, actually what is happening, this cone is now resisting, this cone is involved in resistance. So this cone, when it is penetrating into the soil, we are actually, this cone is experiencing resistance. It is trying to penetrate into the ground. Then we can see the resistance from the cone. We are resistance. For example, if the cone resistance is more, obviously we can say the soil is strong. The soil is strong. If the cone resistance is less, we can guess, being an engineer, so the soil is soft. The soil is soft. The idea of penetration test, if the penetration resistance is more, the soil stiffness is more. If the penetration resistance is less, if either it may be standard penetration test or it may be cone penetration test. But remind you once again, in cone penetration test, we are penetrating cone into the soil. We are penetrating cone into the soil. The end of the drilling rod is attached with cone. This cone have a particular specifications. Keep these specifications in mind. It has a 60 degrees apex angle, 60 degrees apex angle, and it has a overall diameter 35.7, and its end area 10 centimeters square. Now, let me discuss you. For obtaining cone resistance, the cone is pushed. The cone is pushed down. So I am penetrating cone into the soil. Push it down. Push it down. That means here, let me tell you, this is static action. This is static action. Please keep this point in mind. Please keep this point in mind. I'm telling you, when you are pushing the cone into the soil, it comes under the category of static energy. It's not dynamic energy, because I'm pushing the cone into the soil. So now push it down at a steady rate of 10 mm per second. 10 mm per second. The cone is pushed by applying thrust. If you're not happy to use this word, thrust force. Next, after cone resistance is determined, the cone is withdrawn. The cone is withdrawn. బయటికి తీసేస్తాం మాట కోన్ మళ్ళీ మనం డ్రిల్లింగ్ రాడ్ ని బయటికి తీసేస్తాం. This is DCPT. So here actually in the same way you can draw now. So this is the casing pipe, you can say sleeve. Now let me tell you, this is the symbol of continuity. Now this is the drilling rod. So end of the drilling rod is attached with core. Now the thing is, we are going to apply dynamic energy. See, as we already discussed in the case of SPT. You know that the way we have conducted SPT. What is the weight of the hammer? What is the weight of the hammer? 63.5 kg. What is the height of the fall? What is the height of the fall? Height of the fall is undoubtedly 75 centimeter. If you are not happy with that, 750 millimeter. If you are not happy with that, 2.5 feet. 2.5 feet. So in any way, all the dimensions are same. So this is what we are doing, have done in SPT. In the same way, we are going to discuss dynamic cone penetration test. But the only difference here we are trying to highlight is we are attaching the end of the drilling rod. This is drilling rod. The end of the drilling rod, this is a hollow pipe. End of the drilling rod is attached with cone. What is the apex angle of the cone? So you know all these things. Okay. What is the overall diameter of the cone when it comes to the base? When it comes to the base, you know that this is the inverted cone actually. You know the basic idea about cone. You know this is apex. This angle is apex angle. This is base. So the overall diameter is 35.7 mm. This is the diameter. The apex angle is 60 degrees. Now actually we can write now. Now the cone is connected to the end of the driving rod, end of the drilling rod. So the thing is we are going to apply dynamic energy. So we are trying to put the driving energy. So here the weight of the hammer is 63.5 kg. Some books may be rounded up. They are trying to write 65 kg because we may not remember that figure particularly 63.5. Sometimes books also use it to write 65 kg. There is no issue. And also the height of the fall, it is very important, 75 centimeter. Now we are driving the cone. Now we are driving the cone through a distance of 30 centimeters. That means if you are not able to remember 1 feet, 1 foot. Now the DCP, now what we are doing here, we are trying to count number of blows. We are trying to count number of blows for every 10 centimeter penetration of cone. So for a distance of for a total distance of 30 centimeter. Maybe you can recollect our days of SPT where we are trying to drive the split spoon sampler to a distance of 45 centimeter. But whereas in dynamic cone penetration to a distance of 30 centimeter. So we are measuring the number of blows taken for every 10 centimeter penetration. So like this. So I can write here number of blows. Okay. So and very important, depth of penetration. So we are discussing penetration tests. So like that, here I can write 0 to 10 centimeter, 10 to 20, like that, 20 to 30. Now the number of blows may be 2, 4, 5. This is the way we use it to measure the cone penetration resistance.